Share. Copy link. Okay. All right. And alright, deze gaat het wel. Deze doet het wel volgens mij. Yes. Ja. Okay. Yes. Alright. Ben ik een beetje te horen? Want het is, ik heb het vanmiddag getest allemaal, want toen werkte het. Alright. Deze erbij straks. En dan die. Oké, dankjewel Kit. Okay, then I will wait for a few people to come from the other stream. I hope they saw the link. I don't know what happened. It went corrupt for some reason, and yeah, maybe it was reserved too far advanced. Anyhow, let's go start with my face. Hi there. So, this is me. Let's talk about the radio a bit. I've been, I've been to a few demonstrations recent years, and I found out that during demonstrations, like actions, direct actions, that the communications was a difficult part. A lot of activists leave their phones at home, rightfully so, but don't bring other means of communication with them, and that can also make things quite difficult when the heat is turned up. I experienced this myself in Amsterdam. It was like 2 years ago. We had a situation where we had a demonstration in different positions, like in the area of operations, about 500 meters apart, but we couldn't see each other all the times. But there were no comms. So what they did was they appointed someone to run to the different points to ask how everyone was feeling and everyone was going. Yeah, like a runner, you know. And I had something like, yeah, but if you had walkie-talkies, things will be really fast. And that's how I came to start a little organization to provide intel and information about communications during actions. Let's just start. I prepared a PowerPoint presentation. It's like school again. I'm not really a streamer, so if I come off a little nervous, and yeah, then just that's it. That's just how it is. All right. I need to go to the. That's not testing stream. Oh no, that's not this. This one. Yes, there we go. All right. We'll put a station there. Let me move this one over here in the corner. That's very good. Okay. Now, welcome all to this presentation about Comms for Activists. I try my best in my broken English to convey my message well to you. The purpose of today's live stream is for activists, tech savvy or not. I try my best to make it approachable. To get some hooks into considerations for comms. Like, I'm not going to tell what comm they need to use, but I go to explore the world of communications with all of you present and the people watching later. And so you can decide for yourself which direction you want to go and which is fitting for your action group. And I think it will be nice. I try my best at doing this, so let's roll along. Okay, first things first. A disclaimer and common sense talk takes about 2 minutes, and you just need to do this because we're talking about radio waves and we're talking about transmissions, and it's also called TX. So a transmission, if you have a radio like this, like a handheld transceiver, and you press this on this button on the side here, then you do a transmission. You're actually sending radio waves out in the ether, and that can be limited by law and different factors. So we need to have this talk first. So we're talking about transmissions, also called TX, so remember that. And most countries, like the Netherlands we live in, well, at least I live in, have limits on what frequency you may use freely. So you can not TX on everything. Sometimes you need a license, like a ham operator's license. Some frequencies are free to use, but with limits. Most countries have a power limit for TX, and it's often in milliwatts. So for an example, this handheld transceiver works on PMR 446, has an output of 500 milliwatts. That's the legal maximum in the Netherlands for these kind of transceivers on that frequency. Most countries have a limitation on encrypted TX, and especially for if you're a ham radio operator and you're working in the ham bands, then this is kind of really something you need to not really worried about, but think about. Yeah. Encryption is not always allowed, and there are also countries that just bluntly disallow encryption at all. So take that into account. Most countries allow for reception, and it's called RX. So reception, if you see RX somewhere, then I mean receiving signals, and if you see TX, then I mean transmission. Most countries, not all, allow reception of all signals. There are still countries in the world where it's not allowed to receive certain military frequencies. You can actually be, you can go to jail if you do that. So take that into account. So I'm not going to tell you what to do and what not to do. What I'm going to tell you is don't transmit on frequency used by emergency services. So stay away from P2000 and C2000, and you'll be fine. To me, and for the rest, I don't really care. I'm not your daddy. I'm not your father. Feel free to do whatever you feel like. All right. So without the way, we need to talk about some basic theory and stuff. So I was wondering where actually I will put this in the presentation. I thought more in the middle, more in the end, but I thought let me just do it at the beginning and let's get over it, because we're talking about radio, and there are some terms I'm going to use, and it's handy if you know what terms I'm talking about. So let's talk about some basic glossary here. All right. So basic terminology. A frequency, how I define it, is an oscillations per second of a carrier wave in hertz. Well, that's a whole lot to work around it. So I'll put the image there. So you can see what comes out of the antenna here. So I've put my full. I have here a radio, and on top here there's an antenna. And when I press this button here, then it starts radiating radio signals out, and it does it on a certain frequency. And it actually is radio waves, electromagnetic waves going up and down. You can see them, you can feel them go really fast. They go at the speed of light. They're coming out at a certain frequency, and they look like the blue and the red ones here. And the faster they go, like per second, the higher the frequency is. So they go really fast. So on this radio I had over here, if you see in the left corner, you see the radio holding again. It works at PMR 446, and that means 446 megahertz. So that means that from this point here to the next stop, that's actually a whole period, or from here to the other middle, there's a period, and it does that actually 446 million times per second. So that's the frequency it's running on. So and frequency goes in hertz, kilohertz, or megahertz, and hertz stands for heart in German for some reason. I forget that. Okay, so the faster this thing is going up and down, the higher the frequency. All right, and so we have a whole frequency spectrum in the world. We come back to that later. Oh, I need to go to this one. Yes. We also have bands. These frequencies, we have different frequencies, low frequencies and high frequencies, are split up in different bands. There are a lot more, but I only put 4 here because we're talking about these 4 only. So we have medium frequency, that's about 300 kilohertz to 3 megahertz. You can think about AM radio, like a world radio. Some people still have, like from their grandfather, an old a radio which transceives AM transmissions. This is in the medium frequency range. Well, then we have HF. This is where a lot of hammer band users, operators are working in, because you can make long distance communication calls with HF. Then we have VHF. VHF is known for like the 3 meter, like the normal FM broadcast. If you turn on a radio, a normal FM radio, and you tune it to, like, for example, like 96 FM, that actually means 96 megahertz is in between the 330 to 300 megahertz is a VHF frequency. All television signals are also VHF. Some of them, so others are UHF, and also Mariphonie, like communication on ships, is using VHF. And now UHF is the ultra high frequency, is from 300 megahertz to 3 gigahertz, or 3000 megahertz, and that's actually used by this, because this one once was 446 megahertz. So this is a UHF walkie-talkie. So out of the way. Okay, then we have a picture there, and then you can see the whole the spectrum from left to right, and you can also see the wavelength in between there. So you have the different types of equipment using different types and different slices of the frequency. Yeah. All right. Okay, so in summary, we have a frequency, that's oscillations per second of a carrier wave. And the carrier wave is just the thing that carries your voice or carries the data over the frequency. In this case, in this radio again, I showed you again in the left corner, is again 446 megahertz. And we have the bands just described. So let's go through them. An example, a signal of 446 megacycles of megahertz is a UHF signal. All right. Now we talk about a wavelength, and we have a nice little symbol over here. It's lambda, they call it. I forget it, but now we use it. We're going to use it because we come to that later. It's a distance a radio wave propagates in one oscillation. So we had this one over here. So from this point to that point, there's one oscillation. So there's 1 point. So there's a distance. There's also traveling a physical distance. And there's a radio wave propagates in one oscillation, so often in meters or centimeters. And the radio waves travel at the speed of light in c, or in this case called v. And the speed of light is about 300 million meters per second. That's really fast, actually. that's really fast. So we have an equation for that. You don't need to use it, but it will come clear why I put it there. Okay. Because we can translate the meters which a radio wave has to a certain frequency in megahertz and vice versa, and you can use this equation for that. We're not going to use that today. We're not going to make a math class, but I put it here so you can see in a later slide what it's using for. So you can see here as some examples, 300 megahertz is like 300 million hertz, travels 1 meter during one oscillation. And 100 megahertz has a longer wavelength because it oscillates slower, so it travels longer. It travels about 3 meters during one oscillation. And 900 megahertz travels about 33 centimeters during one oscillation. Yeah, all right. So why is this important? Hang on, I will get to the point here. Let's test this together. Often a specific frequency of a small part of a frequency band is called by its wavelength in meter or centimeter. So sometimes we have ham radios talking about the 20 meter band, you know. Yeah, some people don't know what that means, you know. Most people don't know what it means, but by what it now scaffolded up, you can now know what it means. You have the formula, you don't need to use it, but I will put some examples which you can see right now, because it's as activist who's interested in comms, even if you're not tech savvy or not, it's actually good to know which frequencies there are, which bands they're using, and what their common names are. So by knowing a certain frequency or wavelength, it's easy to look up where it's for. It just makes it easier for you to look up where it's for and what you can use it for, what capabilities are, that you're not by accident transmitting on like emergency services, and that you don't do stupid things. That's nice, right? Okay, so some important examples are coming up now. So I have a couple of slides with some frequencies which are of interest. All right, let's go with the lowest bands, like in frequency, and they have actually the longest wavelength because it's inverse correlated to each other. We have the medium frequency and the high frequency bands over here. We start with a medium wave, and this is where the AM receptions are. So for the people with the AM receiver from their grandfather, or maybe they still have it, a new one, this on the medium wave is about 530 kilohertz to 1.8 megahertz, about there. So there's a really long wavelength. Now, then we have the first actually usable ham band and usable for tactical and strategic communications. And there's the 160 meter band, and that operates about 1.8 to 2 megahertz. Is during the night time is being used, and it's a nice band for NVIS, and I will come up later about what that is. The same thing counts for the 80 meter band. The 160 and the 80 kind of act the same. 160 is sometimes needed if the conditions, they call it some conditions, if I will come back to that later in the NVIS example, are bad, and then we switch to 160. The 40 and the 40 is also a good nighttime long distance band. I mean, the 20 meter band is a good long distance during the day band. And the switching between day and night has to do with the solar activity and the ionosphere layers in the atmosphere, the ionosphere, and they dissolve and they construct and they coming together during the day and dissolve during the night, all the way around. So, not making it too technical, but it has to do with the layers. That's why some bands are better usable during the day and some better during the night. Then we have the 15 and the 15 meter band. I don't use it a lot, so I don't have so much to say about it. So if some people has additions to it, feel free to add to it in the chat. I don't use it. It's being used a lot actually, and people are really like ham radio operators are really happy about it. Now the next one I know is the 11 meter band, the Sittenses band. It's like in the Dutch they call it the bakkie. Like the truckers, they have these things in the truck and a big antenna on it. And they, of course, spam out illegally amounts of power in these things, and they can have a little chat over voice with each other while they in the trucks. It was a long time illegal in the Netherlands. I think during the 80s it became legal, and now it's still used, but not that often again. And then with the 10 meter band is ham radio band is being used a lot. I used it a few times, but I'm not really interesting. It's on the higher side of the HF. And that means its propagation, long range propagation, is starting to have diminishing effects. And it's starting to, I will come back to that later. Okay. Then we have the, I was there already. Okay, let's continue, because otherwise we never finish. Okay, we have the VHF, UHF bands. We're starting with a 3 meter band. If you Google 3 meter, and then you get a lot of equipment for pirate radio stuff, like the 1 kilowatt transmitters and the dipole antennas for it. Really nice. But it's actually FM. It's like your FM broadcast. It's like 88 till 108 megahertz. Like if you turn on the radio on FM, this does you hear. There's a 3 meter band. Then we have a next one, the air band. This is where pilots and commercial air traffic is communicating over. I put that, don't TX. Whatever you put in your mind, if you have hardware capable of doing a TX over there, don't do it. Just don't. Then we have the 2 meter band. Is a lot being used a lot, like I said earlier, in like on sea, like a Mariphone, and also being used a lot by ham radio operators. And I like it. I like VHF really a lot. I use it a lot. I also have a dual band antenna with VHF and like the 2 meters and the 70 centimeters. I have it on there. I really like that. Then we have the P2000 and the C2000. The P2000 is the unencrypted version of C2000, but they're the same. These are for emergency service, police, fire department and thing. If you have equipment capable of doing a TX over there, please don't. And you will be fine. Then we have the 70 centimeter band. Well, this is the UHF band I use also really a lot, and I think the most of you is going to use this band a lot together with the PMR 446. So the 70 centimeter, the PMR 446, and the LoRa 868 on the later page is going to be used a lot. So pay attention to these, please, because these are going to be very useful in cities for short range communications, like with these things, like in the left corner you see again the walkie-talkies. All right, let's continue with the dry stuff. Okay, we're getting there, right? Then we get to UHF, SHF. SHF stands for super high frequency. I didn't mention it earlier, but we don't use it that much. Yeah, we use it a lot, but it's abstracted away such a lot that we don't use it by the frequency a lot. What is of interest is the SRD short range device 868, also LPD low power device. The names are interchangeable. I always use LPD for 433 megahertz and SRD for 868. Otherwise I mix them up, but people using them over and all. Just call it 868 or LoRa, and people know what you're talking about. Now, LoRa is being used by Meshtastic, Meshcore, these Reticulum R nodes, and a lot of these LoRa devices using this SRD band. Because why? It is it's free to use. It has a high power, high throughput. It has actually a broad there's a broad slice to use for free. There's no license needed. You don't need to pay anything, and you can transmit with 500 milliwatts on it. So that's why it's used a lot for long range. LoRa stands for long range radio. LoRa, long range. Yeah, that's why LoRa is being used a lot, because it's free to use almost all over the world. Now then we have some technical stuff like 4G LTE, 5G, 23 centimeter is a ham band being used a lot. The 30 centimeter is like ISM, it's like Wi-Fi, Bluetooth and thing. But yeah, it's nice to know if you're interested in some packet sniffing or something. You do have some Wireshark with a HackRF and you want to sniff some Wi-Fi stuff. Then this is really interesting to know. But for ActivistCom, it's not really interesting because as activists we don't do the sniffing. We try to communicate with each other, and Wi-Fi and Bluetooth is abstracted away that you don't need to know the frequency itself that much. So that's why I put them there, because we use them. But yeah, all right. So I can understand this maybe a lot for you to digest at one time. I'm a little bit dry, a little bit theoretical. And that's why I put a copy of this whole presentation I put on my website. You can download it for free. It's a PDF, so feel free to do that. All right. So the main question: what are comms? Let's go. All right. What are comms? Now, what I'm doing is communications. So comms is shortened for communications. So this word communications. So the concept of exchanging information between two entities. So me talking to you, you're not able to talk back, although you can talk back through the chat, is a way of communicating. So two people talking, just me in a room with someone is communications. Bird chirping, reading a book is communication, because the author wrote something down, you reading it. It has a big ass delay on it, but it is communication. Sending an email, doom scrolling in Instagram, telephone call, using radio equipment, this presentation. It's all communication. So yeah, all right. So but where are we interested in? Well, we are talking about radio equipment, right? That's why this presentation is for. So let's talk about these little fellows, the Baofengs. I think almost everyone in the activist world knows what a Baofeng is. It's just this handheld transceiver. They call it a handheld transceiver of a walkie-talkie. I use it interchangeably. Walkie-talkie, handheld receiver, portofoon in Dutch they call it. These things are capable to transmit up to 5 watts. Officially you need to have a Hamler radio license to operate this thing. But yeah, just stay away from the airbands and emergency services, and I don't care what you do. All right. And we have a lot more of equipment and styles and things. So we have also ham radio, like HF, an HF rig, is an old one. I don't have it. It looks really nice. I just looked up on the internet and I thought, oh, this looks like a nice rig. Let me put it up. And we have like these LoRa devices, like Meshtastic and Meshcore devices, and these reticulum AirNote things combined with a phone. We have Kiddie walkie-talkies. These are really nice. I also have a pair of these things. These are crazy as cheap, and they work. They work. If in an open field, they work up to 3 kilometers. That's really great. It's just a PMR. They are valid. They are valid to use during actions also. You have Briar that is using Bluetooth on your phone, so it's direct P2P connection over Bluetooth. I can't recommend it, but it is communication, right? We have Zello. It's like a PTT app. PTT stands for push to talk, so it's like a walkie-talkie app for your phone. We have a repeater system using VHF, UHF, like what we talked about, but a repeater is just receiving a signal and is rebroadcast it with a broader range, so you have more range. It's really nice. Then we have Satcom, satellite telephones. You always see them in this movie where the criminal walks around in some kind of country where shit happens. And they have a sat phone to give instructions of, I don't know, darkened users. Then we have, of course, our radio, our FM radio or a world receiver. Really valuable piece of equipment to have. It's, people think it's simple, but it's maybe this is one of the most important parts of equipment you can own. Especially, I don't know what's going to happen in this world. Maybe 5 years, you never know. SDR. This is SDR dongle, the RTL SDR. I don't have it. I have a Hacker ref. But this is a nice entry-level SDR. And what the SDR is a software-defined radio. And you can receive signals with this little antenna over there. But really on a broad scale. So from really on the lower, sometimes on the kilohertz range, like in the world receiver range, like AM range, up to a few gigahertz, up to like the I don't know if this specific one can do it, up to the 5 gigahertz Wi-Fi. It's a lot, and you can receive any signal. You cannot transmit on it, but you can receive. So it's a really safe introduction to learn about radio propagation and signals, because you cannot screw it up. You cannot accidentally send something to airplanes or to C2000. You know, it's a good way, good thing to do. So a question later, but I come to the Q&A later. So wait, maybe I can check it. I forget. Can this device be? How's this something? Can this device be jammed easily? I don't know what you real Raxus. I don't know what device you mean. So if you can continue that, then can elaborate on that, and then I'm happy to answer your question later. All right. So we have this. This is a Foxhole radio. It's actually a really simple AM receiver, and you don't need batteries for it. It uses a rectifier. Normally you use a diode as a rectifier, but it uses a pencil and like a noded, how you call it, a razor blade. And because of it touching really like lightly, the electrons are only allowed to move one way. It's actually rectifying it, and that's how you can make an AM receiver and a coil there to tune. Really crazy. People can make it for fun. They're really hard to tune, and they're really hard to actually receive something on it. But people made them. I never made one, but they tend to. It can be fun for the Boy Scouts or something. You know, it is can be fun. Then we have this. This is a spark gap generator. And it was used back in the day when radio transmission started. It was with spark gap generators. This was actually to transmit CW, and CW stands for continuous wave, and that actually stands for Morse code. So this under here is a Morse code key, and when you press that down, you short it, and then a signal, high frequency signal, was being spit out on the waves, and it uses this equipment. It's like about 200 years old or something. I don't know. It's really nice. And then, of course, have the military manpacks. I don't know exactly what model this is. It's about late 70s, I think it is. But you can see here on you have this antenna, you have the receiver, and I think it's some encryption. This, I think, is an amplifier. I think this is a receiver and a battery model. I'm not sure. I really don't know. I'm not talking bullshit. And I have a handset here from. This is being used a lot. It's like for tactical comms and strategic comms. Really nice. We have Satcom. So this is your DVB or DSB, I don't know what they call these things, like these LNA blocks with a dish you mount on and you aim them at the satellite, and And the satellite receives signal from an uplugs into the satellite, and you can watch TV via satellite dish. Really nice. And also the SATCOM works in the same principle, but it's the same thing. It's just communication via a satellite in the air. Now we have digital modes like this is like FT8 or JSCOM. You can use this over different types of radio. This to how you call it, send and receive digital transmissions like text. We have Reticulum of HF radio. Reticulum is it's really nice. I will come back to that later a little bit. We have WinLink, sending email over radio, over packet radio. We have APRS, Automated Packet Reporting System. It's really nice because you can, if you're with a group of friends and you're hiking and you have a radio that's able to send and receive GPS data over radio signals, you can use APRS to report to each other. So if people get lost, get in a slide or something, or get lost in the woods, you can try to find them back. APRS is suited for that goal. Then we have packet radio. Packet radio is really old, like I think in the early 70s already it started, and it's still being used. I'm still experimenting with it. I really like it. So you have a radio transceiver over here, like any radio. It can be just any of these in the left bottom corner here. It can be any one of these. You connect it to the side. You connect it to a TNC, a terminal node controller, with its input-output, and this terminal node controller controls the radio, like you pressing the button or not, and the computer communicates with the TNC to extract the audio data and act as a modem. Really nice. You can send messages just using a simple transceiver, like a handheld transceiver with this. And of course we have our Wi-Fi modems. There's also really valid, because with Wi-Fi you can make point-to-point connections. And we have controllers for drones. And the funny thing about drones is you have two kinds of connections. You have a connection for the live feed and a connection for the controller of the drone itself. So you have two types of radio frequencies operating on this thing. But for controlling remote equipment, radios is really worth it. And especially as an activist, you need to know what frequencies these things use. And so you can mitigate jamming, or you can maybe prepare to jam them. I don't say you should do it because it's illegal, but you never know what's happening with drones. Drones are being used in the world, and to be honest, I find them kind of terrifying. So that's it. So why are radio comms important to activists? Well, we know this, right? My phone works and is more convenient. Yeah, that's true. It's really true. My phone works too. I really like it. It is more convenient. But cell tower and service dependency. Government can shut down access or tap your conversations. By law, cell service providers are required to enable tapping by the police if they get a warrant for it. So yes, if you have a normal phone call or unencrypted data is going through it, they can sniff it out if a judge approves for that. But the judge doesn't need to let you know beforehand, so it can be anytime. Can contain personal data and metadata, especially on your phone, because your phone, you have it with you. You use your phone for everything, for social media, for your work. There's a lot of data bound to your profile, to your person in your phone. And do you know what is being sent over the internet with if you use an app? If any of these data, they say it's secure, but not everything is so secure, and a lot of metadata is actually doing the trick there. They can make a profile to inform you, and these metadata, if they have a lot of metadata from it, they don't need actually to know who it is, because the fingerprint of the metadata actually makes an entity that is linking to your phone. And if your phone can be found, then you can be found. And that's the thing. So phones are really nice. I really like them. It's my primary way of communication. But they have limitations for activist use. So, and I have the next one. Why are radio comms important to activists? And I have internet at home and Wi-Fi at work, school, right? So why do we need communications like on strategic level anyhow? We have internet works, right? Yes, that's true. We have Wi-Fi and everything works. And in the Netherlands, the internet is actually considered kind of good, actually, if we talk about uptime. But yes, there we go again. ISP dependency, ISP, Internet Service Provider. You pay them, they provide your modem, they provide your network. If somewhere in there decides that you're not allowed to have it, then you don't have internet. So simple as it. And of course you can connect to free Wi-Fi. That's easy, but you're dependent on a third party. Government can shut down or limit access. We saw it in Iran. We see it in Bangladesh. We saw it in different countries in the world where the heat is being fired up. And the government has something like, no internet for you because it's too much freedom is too dangerous for us. So they just shut it down. And who says it cannot happen in the Netherlands? So, I mean, it can happen anywhere, right? Can contain personal data. It's actually the same as your phone. On your device using Wi-Fi, you're sending over and you're saving cookies on your browser, and these cookies getting shared on different websites. This is just an very easy example, but after a while, different hardware IDs are being shared also, and these hardware IDs are linked to behaviors, and these behaviors can be made to build up a profile, and this profile can be linked to a single entity. Because if one time that hardware ID, like a MAC address from your network card, is linked to a GPS coordination, has to be one slip up, you can be found easily. So yes, there are limitations for internet use. For general use, internet is safe. Please keep using it. But if things are getting heated, internet can be a dangerous place. So why are radio comms important to activists then? I have two primary reasons actually, and I put them in this order because I think right now, as of how we live in the Netherlands now, how the freedoms kind of still up, this is the right order. We use it as a backup tool first and as a primary tool later, but sometimes we use it as a primary tool. It's better during some kind of direct action. As a primary tool is better, but we'll come back to that. Okay, so as a backup tool, because if you have no cellular service and the internet is down, then we are really tied down with our hands. So what you're going to do then, right? You're going to put a bottle in a message in a bottle and send it. Well, I think a lot of people don't think about what happens if both of these at the same time are shut down. It will be really interesting, I think. I think we are so used to the internet that, we will see. But the radio can be used. You can use HF to make long distance calls. Of course, you cannot download a torrent movie from for 2 gigabytes. No, you can't. But you can communicate. You can send an email over WinLink. You can use Reticulum to maintain connections and to communicate with your people. You can still have local communication with your neighborhood with walkie-talkies. So there are ways to have communications being set up, being worked out when there's no internet. But yeah, you need to expect, you can't expect movie downloads. That's it. As a primary tool, you have way more control over what's being sent to another party if you use radio. You can from bit to bit, every bit you can control what you're going to send. If you push the PTT, if I let me go to the fuel. I have my radio here. I control this thing. This thing is, I can turn it on, but I'd only send something if I press this button here. It doesn't know anything. It's not like my phone. If I put my phone on, if I turn my phone on, it's starting to look for a cell tower. It's setting up IDs. It's probably broadcasting as EMI. And you're already broadcasting yourself. So that's the difference. This thing doesn't do. Of course, this is not a phone. You cannot watch movies with this. You cannot, it's just a single tool for communication in short range. But you have full control over it, and that's worth it. So going back, you have direct P2P connections, peer-to-peer. That means from one person to directly one person. Communication is possible. There is one exception, as the Briar app and the Zello. I think Zello also can do it on your phone. But besides that, that's with the phone or with the internet, you don't have P2P. You make use of a network. You go to your ISP. ISP goes to some kind of node somewhere. I don't know. I'm not really a networking guy, and it's going to some resolvers somewhere, some DNS, and then it reverts back to IP addresses, and these IP addresses going back to some other front end and resolves a website for you, for example, and turns it back. I don't know exactly how that works technical level, but there is a lot of linkage going on. You're going through different layers, different steps, and anywhere on this line, this data can be stripped off, snooped, can be watched. Of course, with TLS and SSL, everything is encrypted, but I don't know, it's still not P2P. Also with the radio, it's fast to initiate contact. If I want to make a call with this one, with my phone in the left corner, I need to dial. I need to dial a number. It takes a couple of seconds. With this one, if I have it on, I just press it and it transmits. It's fast. It's really fast to initiate contact. So that's why for tactical communication, where speed is of importance, it's really nice to have. And like I said a little bit earlier already, it's no or limited dependency on third parties. So no ISP, no cell towers, no waiting for service, no governments. There are, of course, rules and the laws imposed on radio wave communications, but in the end, if it goes about who has equipment to send something from A to B, and there is no law, then you can send things from A to B with a radio. And with your cell phone, you can't if there is no cell service. All right. There we go again. Why this thing? There we go. Yes. So, and both reasons are valid and complementary. So, as a backup tool or a primary tool, I don't care. It's both the reasons to have radio communications is valid. If you think that in the next couple of years there will be war in the Netherlands, you want to prepare for that, it's fine. If you want to use this primary tool for activism, it's fine. If you don't think there will be any war and you don't want to use the backup, it's fine. You can use the primary tool, but they're complementary, because I think if you use it, if you want to use it as a backup tool, but you're also using it as a primary tool, you're starting to learn how to use the radio at the moment when you need it. You can rather learn to use it when the times are easy than I have to learn it when the times are hard. So that's why I think it's complementary to each other. And you can make up for what you want. I think both reasons are valid and work along with each other. All right. So now we're going to get to the question: what type of comms should you use? Well, that depends on a lot of variables, and feelings is one of them. But let's spit them out. So you have, of course, our main factor, and it's budget. It's hard to talk about, but the budget is a thing, and especially when we're talking about communications for activists, and I tend to use the word cost per operator here, CPO. Because if you're an activist group and you will maybe have 100 people in the activist group and 10 people are becoming radio operators for the purposes you have, then you need to, of course, set up radio communications for these 10 people for use. So, and all the total costs are being divided by the amount of operators. So imagine you have for 2,000 euros you buy equipment for 10 operators to use, then the CPO is 200 because 2,000 euros divided by 10 people is 200 euros. I come back to this why I put it like this, because it's a kind of convoluted way to say budget, but okay. And you have the range is also important to decide what comms you use. And I have a rule here. I made it up myself. Yeah, I don't like the 0.5, but yeah, it is a really important one actually. So yeah, I have to put it there. That's the 0.5, 550, 500, 5,000 rule, and it has to do with the range. It is kilometers. I will come back to that. Then you have the utility. Where are you going to use the comms for? I have three main utilities here. I have casual comms, tactical comms, and strategic comms. All three of them, I think, are have their own flavor, and make you decide which one you want to use. You have your group size. It's a rather small one, and depends if you have 2 people, 3 or more, and you have a central command or not. Environment. Are you operating in a rural environment or a residential environment? That can be a decisive factor for what types of comms you're going to use. And then we have simplicity. And I need to move my head away. And let me put it on the right top. All right. And simplicity is easy to use or skills required. And I put this as last because I want to end there. And I think that's the simplicity is I think one of the most important parts of this demonstration. And I think there was where the most failures are being made, and also by me. And I'll come back to that. All right. So we have a mnemonic for that. I had to make something up, and I was shifting these words and I was moving around. I couldn't find. And I thought, oh yeah, what was the French word for Brussels again? Oh yeah, it was Bruges. So I put a Bruges. Okay, so remember Bruges? No one will remember this. Bruges. All right. All right. And that's the thing. That's the six factors I think that make up a good decision for you to choose comms. Yeah. All right. So we start with budget, CPO, cost per operator. Now, I think for activist use, like for us activists, like for human rights activists in the Netherlands, Europe, around a CPO of about 50 to 100 euros is a healthy aim to have. So that's on the bottom one here. I think 50 euros nowadays. Of course, this will change with inflation over time. I think it's a little too skimpy. I think you're making compromising choices that sometimes do more harm than do any good. And a CPO of more than 100 euros, I think, is not worth it. Not for our use. We're not militaries or something. Bruges, Brugge. Oh, thank you very much. Okay, see, I'm not Z-free, thank you very much. I think maybe you're right. Because wat is Brussel is dan Bruxelles, denk ik. Bruxelles met dubbel X, right? Yeah, all right. Never mind. A CPO of more than 100 euros, I think for our for activists in mind, I don't think is worth it. It doesn't make sense to buy an expensive 2,000 euro HF rig if you want to do demonstrations like have comms during a march in Amsterdam or something. I don't. That makes no sense, you know. So we are not doing paramilitary stuff over here that we need high-end encryption or high-grade stuff that is extremely rugged or something, and that costs many of thousands of euros even per operator. So we don't. So you can keep the cost low, and the cost budget is a factor. I know activists, money is a thing. It's a factor. We cannot deny that money is a deciding factor. So CPO is there. So let's continue about that. So an example of a too low CPO. So and I have an example here with the Baofengs, with the Baofeng walkie-talkies. So an action group just buys Baofengs for 30 euro each. It's very cheap. You can buy them for cheap. And it doesn't matter any action group, because I didn't put the size there because I just buy them for 30 euro each. So CPO is automatically 30 euro, and every operator buys one Baofeng for 30 euro. So CPO is 30. Factory shipped with antennas, they're not so great. These Baofeng things, not so good. Will affect usable range. Reception is poor. An area of operations coverage not guaranteed. So if you're doing like a march through the city, and the march is kind of big, and use Baofengs, well, good to you. But yeah, he was skimpy and he didn't want to change antenna because new antenna costs 20 euros. And let's just use these Baofengs for 30 euros and let's do it. Yeah, you will see that the same with PMR. You will cut loose sometimes and miss some voice, and that may or may not be a problem. So I think this is a little bit on the low side. So a solution will be just buy better antennas for these Baofengs. And these cost about 20 euros each. You can get them cheaper, but then the quality is not guaranteed. About 20 euros about a good thing. You get these Retivis or these Niagi or so antennas. And these cost about 20 euros. So that adds up to the 30 euro because every Baofeng needs one antenna. And then 30 plus 20 is 50. So you have a CPO of 50 and it makes it more in range of what we think. Result, better reception, AO coverage. Improved. AO stands for Area of Operations. And it's already standing here also. Yeah. All right. Yeah, so it is just a tool. It's not I'm saying you have to between 50 or 100. No, it's just, hey, if you think, if you was looking for comms for your action group, and think, yeah, I was looking for Baofengs, I found a really cheap, a 10 pack for like 200 euros or something, and just buy them. Well, I hope you now think about, oh yeah, maybe we need to check the antennas. No, and if I did that to you, that's already worth it. All right. Yeah, CPO can also be too high, I think. Example: an extra group, 10 members wants HF rig for high frequency, for long range communications, and a rig costs €2,000. Yes, they can cost €2,000, a single rig. And about 10 people are going to use the rig, maybe, and have a CPO of 200. If Action Group also needs walkie-talkies for the tactical coordination, but yeah, the money is gone because the rig was bought. The investment did not help the group goals because the area of operation was not covered by tactical communication. Only the strategic comms, the long-range DX comms, were covered by a HF rig. It's a good rig, probably it works fine. The antenna is fine also. But yeah, now with the direct actions on the location and is communication needed, there's no communications. There are no tools, and the CPO already really high, and the budget gone. Well, solution: just buy a decent second-hand €500 rig for HF if your action group needs HF, and some decent new walkie-talkies like the Baofangs with the proper antennas. Now, and then some calculation here. I paid a CPO of 100. You put it down a bit within a healthy range. 500 for the HF rig, 500 for 10 Baofangs plus antennas. Well, and your result is you still have HF capabilities, proper tactical comms, and still €1,000 in the bank for other goals. I don't know. So it's just a tool for you to think, and it's not saying you have to do this or that. No, it's just think about it. I'm really a bad example of how I act because I like expensive shit. So yeah, there's more, maybe more a note to me. All right. Okay. So what is an example of a healthy CPO? So an extra group 10 operators want to set up mesh communications. Well, mesh communications are kind of hot nowadays. It started with Meshtastic, and now Meshcore is hot, and Reticulum is kind of interesting also. So yes, mesh is. I understand why people are interested in mesh communications. And so in this example, an extra group 10 operators want to use mesh communications, so Meshtastic or something, and they want to use TDEX because they don't want to bring a phone to the location because of email sharing, and they don't like it. So they want to use standalone devices for Meshtastic or Meshcore. So they need to use these TDEX things because they can be used standalone. Now these TDEX cost about €80 or something. Now they buy 10 of them. 10 TDEX are bought and prepared for use with Meshtastic. Now, and a single LoRa board with decent antenna is being used as a repeater. It's being put in a backpack somewhere up in the building at the area of operations, and is being set as a repeater. And with a power bank plugged in, cheap power bank from Action, for power. It will run for hours, maybe a day. Total cost for this whole setup for 10 operators, €900. CPO of 90. All members have comms. There's AO coverage by the mesh repeater. It works. It's fine. It's good to use. So this is like a healthy example to set up a communications line. Another healthy CPO. Action group 20 operators by walkie-talkies and a VHF UHF repeater. So now we're talking about the big action group. 20 operators. Imagine how big the group itself is, because not all members of an action group are operators. So in this case we have 20 operators. We have a big action group. They operate in a single city or like in a district or a municipal between different cities, like Amsterdam and the municipals around there. Now you need a repeater because you cannot cover the whole of Amsterdam with just walkie-talkies. That's not possible. So they buy a repeater, mobile repeater. Well, that costs a lot of money. The repeater costs about €400 plus €100 battery. Now you need the waterproofing. I imagine they have a backpack and a weatherproof sack or something to put everything in. Now they find a high-rise building where they have access to put a repeater on top of their antenna there, and they are ready to go. They can do the action because everything, and the 20 walkie-talkies cost €1,000. The repeater costs 500. It's €1,500. 20 operators, CPO is 55. This is a reasonable setup actually. AO is covered, and this repeater actually can do encryption if needed. These walkie-talkies not. Then CPO will be a little higher, but yeah. So this is two examples of healthy CPOs. Yeah. Now, then we have the range. Then we come to my self-taught 0.5, 550, 500, 5000 plus rule. All right. So, as I said earlier, this is range in kilometers, and I think it's good to divide your range you want. So the range you want to operate in, to divide them like this. It's not perfect, but it's a good ballpark. And estimating range for radio devices is really hard by itself. So ballparking like this is good. So I put it like this: 0.5 kilometers, like 500 meters, is your neighborhood. It's like the streets surrounding your street. Is being used for the PMI walkie-talkies. These walkie-talkies. PMI walkie-talkies, mesh nodes, no repeaters. You can use it for like, this is when we're talking about static demonstrations, like we have on the Dam Square. We have a demonstration, we're standing there, and maybe up to 2,000 people are there, attending there, and we have stewards walking around with walkie-talkies, like what ACAS is always doing, walking around there with walkie-talkies. We use PMR 446 walkie-talkies. It's legal, it's easy to use, they're weatherproof, they're cheap, they're nice to use, and it works wonderfully in these small areas. So the 0.5 kilometers is a neighborhood, like range. Yeah. Now we're getting a little step up. If you want a communication in a village or city district, like a wijk, a big wijk, then we are talking about 5 kilometers. Now, and then we're talking about more high-powered HTs. Then we're talking about like the Anytones or the bigger Baofangs that can put out like 5 or 10 watts or something. Then you need a little more power to that, and of course you also need to put yourself on elevation, because just power doesn't cut it. And I will show you later why power is not really the good thing to start cranking up first. The best thing is to change your antenna, but I'll come back to that later. So if you have your village or your city district, if that's your area of operations, then you need to think more in ways of power and repeating, like a mesh repeaters or something. You have more infrastructure going on. You know, it is not really ad hoc. It's getting there. Okay, now we have the 50 kilometer range. We get in a city or intercity. In city, I mean Amsterdam, Rotterdam, Den Haag, Utrecht. You know, these cities I'm talking about, or intercity. I mean intercity, not the train. I mean a city-to-city communication. So neighboring cities talking to each other. Like now, then we need a UHF, VHF repeater or mesh network. And this not really, not anything else is possible in radio comms. There's no direct communications possible without using HF. So you use a repeater, and a repeater is just let me put it on the other cam. Where is it? I have this one here. Got to look at this. So I have here a walkie-talkie here, and I have a walkie-talkie here, and they want to talk to each other. So they're like nice and close to each other. And but now this one is just think with me, is moving away like 10 kilometers away. So they cannot hear each other anymore. So what a repeater is doing, just think of it as a walkie-talkie or a radio, which operates on the same frequency as these things, and is put up on a high building or something with a big ass antenna, high antenna on it, in between, in the center of the area of operations. Oh, that shouldn't do that. And at anything that gets in, it sends out on a different frequency, or sometimes on the same, but most of them on different frequency. So what you do with these radios is you send the receive frequency different as TX frequency, and you do it for all these things, so they can talk all to the repeater, and the repeater sends to the other side the signal. So you can extend your range really vastly with the use of repeaters. That is something no activist actually see it considering, but it is really a valid consideration. The cost is in the €500 range, and it can be really valuable. Yes. Yes. So that's about the UHF VHF repeater and the mesh network. In the 50 kilometer range, you can also start using NVIS. If anything else is not possible, NVIS is a possibility, and I will explain later what NVIS is. I will default to NVIS at 50 kilometers. I will use it at a higher range, because normally with a repeater or mesh network you will get there. So then now we're getting interesting. At 500 kilometers, and that's like a country or national, like a county. I mean, like for big countries, this is like a part of the country. But for the Netherlands or Belgium, this is national. This is the whole country itself, because the Netherlands is like from point to point, the farthest away, like 400 kilometers or something. So, and like bigger countries, it's just a district. So you can think of it like that, like a small country or big county. Yeah. This is the range using NVIS. NVIS, Near Vertical Incident Skywave, or SAT communications, or mesh network. But with mesh network, it's going to degrade really fast, these ranges. And these mesh networks are they grade up to about 200 kilometers or something if they're meshing properly. But then they're starting to have diminishing returns, missed messages. And for if you use the mesh core, for example, you can view this online. You can send message to the public channel and then view online what's actually being sent and what you received. And if you look online what is being sent and received by your reception node, there's vastly more than what you receive on your own device. So it's really unreliable at longer ranges. Mesh networks are like a novelty then, no? Okay, and when we talk about international communications, and we talk about 5,000 kilometers or a little less or a little more, here we talk about Skywave, HF Skywave. It is there is no other way. You can use SATCOM, but then of course SATCOM you have third parties. So if you don't want to have third parties, the only way to have radio communications at these distances is with HF Skywave. There's no other way to do it. It's just not. So yeah, here we have it. Okay, so we're focusing as activists. We are focusing the most on this one. This is the most important, I think, to start with focusing on, I think, as activists. Because as activists, most activists are working locally. Of course, they coordinate nationally, but they work often locally, own city, neighboring cities, they're working close to each other. I think is best is to think about this range. Second is, of course, a national coordination, and that is nationally. Of course, we use Signal app for that, or like WhatsApp, or any app, or internet, or mail. That works for now, but think about what happens, how you're going to communicate with each other on national level. How, for example, is Extinction Rebellion Groningen is to go to communicate with Extinction Rebellion Zeeland. If there's no internet and a phone, how are we going to do that? We're going to send postal pigeons. I don't know. We can do that. It works, but you have to think about that. So I think these two, the 5 kilometer and the 500 kilometer parts, are focus points. I think that's really good to have focus on that. And why? Oh yeah, about the NVIS. So the NVIS, what is NVIS? Yes, I put this in between because I want to explain what NVIS was. NVIS stands for Near Vertical Incident Skywave. So, firstly, normal skywave propagation. So we have the Earth, like the curvature of the Earth there. It's my best drawing, so you may applause, may not. And we have a transmitter and a receiver. In red, the TX, the transmitter, and a receiver on the other side in blue, the RX. And TX want to send something to RX. So we have our atmospheric layers. So with the ionosphere, the troposphere, we have different spheres there, and they have properties at different times of the day and at different solar cycles. A little technical, not going to bother you with that. But they reflect radio waves in the right circumstances, and we make use of that during HF. And that's really nice because we can reach the other side of the world. Now, how it does it? It does a TX, and one of the radio waves there, you can see, is actually bouncing off one of these layers and bouncing back to the RX so it can reach, because something here is obstructing them for direct line of communication. And often that's the Earth itself obstructing it, because the Earth is round and the Earth is not doesn't really like to let through radio waves. So that works. It's called Skywave. This is actually Skywave, and there's a skip zone. So if you here read somewhere Skywave, this is it. Long range communications with a bounced radio wave. It's not more difficult or easier than that. But now, NVIS. How are we going to do that? We have still have our atmospheric layers, but we still have our mountain or obstruction. And now our RX is closer to this mountain on the other side. how are we going to reach them? They're still too far away for VHF or UHF. We still need to use HF, but how are we going to reach them? It's not going to work. This is normal HF. No go. So we need to set up our antenna to use NVIS. And if we use NVIS, we can bounce off more vertically, and we bounce back to him, and we reach them. So that was NVIS. So now NVIS requires HFM frequencies to work. The upper medium frequencies can work during the night. I won't advise it though, because you need long antennas and it's really wonky to work with. Just use your HF, like 160, 80, 40. Those three meters are like the NVIS frequencies. NVIS is achieved by arranging the antenna in such a way that a lot of the radiated energy is directed straight upwards. So up, straight up, and comes back down, reflected back down into the sky. Hence near vertical incidence. So incidence is like the angle in English. NVIS work best between 160 and 40 meters, 40 meters during the night, and 80 and 160 during the night. And that's why it was. I started also off with this little theoretical part about these meters, because a lot of people talking about this in this way, like in meters. And now, if you see 40 meters, then you know, it's like about 7 megahertz, and 80 is like 3.5 megahertz, about, and 60 is like 1.8 megahertz. So if you can change that, then you know what your rig, and you probably have a HF rig that's able to do, not able to do 1.8, and you see 160 somewhere, then you know, oh yeah, my rig can do it. And then you don't, yeah, that's why it's nice to know it a bit. All right. So that was NVIS. So NVIS is really great for intermediate range communication. It is the sweet spot between medium and short and long range. All right. So focus first. My advice would be to focus as action group, if you want to invest in communications, is to focus first on the first one, like in a village, city district, like where your area of operation is mostly that, in city center, and a walk around in different parts of the city, a march, and a static demonstration, maybe some planned actions in a city center. You know, this is where you mostly operate. Of course, you have bleeding over zones. In your neighborhood, if you have static small demonstration, you're in the neighborhood, or sometimes you have more, it's broader, more actions, different parts of the Netherlands, and you want to more coordinate, then you also overlap with the city, intercity part of it. And the same thing counts for the long range stuff. Also, like I said earlier, the NVIS is capable to do the 50 kilometers. It is able to do it, but you know, it is it's on the shorter side. And of course, yeah, sometimes you want to communicate internationally. If really internet and phones are going down, then international, to know what happened on the other side of the world is valuable. Let's see, I see someone talking here. Let's see. This chat is not really. Oh yeah. How long is the skip zone for NVIS? Oh, the skip zone for NVIS is, no, there is not really a skip zone. If you, the thing is, you can put it straight up and then it comes straight down, so you can receive your own message. But that means also your range is limited. But if you arrange your antenna, because you can arrange it with the slope and the height and the distance to ground, and there's different ways to actually arrange your antenna to have a radiation pattern that radiates most of the signal up. You can play with that amount. You have to play with it, and then you can, have a small skip zone, like a skip zone of like 50 kilometers around you. You don't receive, but then you have a further range. But it's not like exact science or something. It's kind of finicky. I have an image somewhere. I can look it up. And then we have the. Let's see where this is. I had it somewhere. Where is that thing? I had the NVIS communication. I think it's over here. And that was really interesting. Where it is? Of course, I can't find it anymore. That's really sad. I have a lot of. Oh yeah, here it is. Let's see. I need to close down this. Let's see. Okay, So let put it there. All right. So I've put it there. This is a test I had a couple of weeks ago, and this is a FT8 test I did, and I don't know what happened there. So I think it's better. You can see the pills, the color pills, the blue pills and the yellow pills. The yellow pills I did on 20 meters, like on 14 megahertz. That was all reception. So I was transmitting from here, from the Netherlands, and all these pills, these colored pills, are stations that receive my message. And you can see on a normal HF, dus not in an NVIS configuration, the yellow ones start to receive me. Close by, there were no people starting to receive me. I had a skip zone of about like maybe 1,000 kilometers or something. Well, from 500 to 1,000, I think, kilometers. They could not receive me. When I switched to 40 meters during the day, and I lowered my antenna a little bit, I started an NVIS configuration, and then suddenly all these popped up all around me, close around me. But you can see at the border with the yellow ones, there's almost no reception. So there is a little overlap, as you can see here, but not that much. So you can select if you want to have closer communication, you use NVIS, and if you want really long range communication, you use the normal Skywave propagation. Yeah. All right. So that was it. Need to go there, and you go to the next one. Yes. Considerations. Let's do considerations. Otherwise, we're going to a really long night. Otherwise, considerations for 500 meters in a neighborhood. Now, of course, that's given. The walkie-talkies, just the PMR, just the simple walkie-talkies like these, even the kiddie ones, the cheap, the action ones. You can use them for an action, for like a static demonstration, perfectly fine. Only thing is, no encryption. But for most static demonstrations, you don't need encryption, right? Yeah, you can, but not needed. The encryption you use more for high-risk stuff, but if you use encryption, you also have more people want to sniff you out. All right. Also, LoRa mesh testing. So these more LoRa devices, like these things, like let me put my camera on full view. Like these things. This one I configured for reticulum though, but this small this mirror, it is really really annoying. And I have reflections, of course. There's a little board in there. It's like an ESP32 board, and there's an antenna on there, and it operates on a LoRa frequency, short range device, and you can use data. You can use from data transmissions. Like Meshtastic, Meshcore, these things. I think the tech workers also had a demonstration about the Meshcore. And I think I refer to that. I don't want to cover too much about the differences between these. I think there's a lot of resources you can find for that. All right. So LoRa Meshtastic I think is really good for short range. And second place maybe there is the Meshcore. Also, interesting one is the direct Wi-Fi P2P. If you're close range, like if you living in the same neighborhood. Like some comrades living in the same neighborhood and are living like on a top story building or something. You can make a tunnel, a Wi-Fi tunnel or something, and use a Cantana for it. And the Cantana is just a Pringles bus, and because a Pringles bus on the inside has this aluminium coating and actually conducts electrons, so you can make a waveguide from it. And if you put a little high gain Yagi antenna in there or something, or so I don't know. You can look at the YouTube. You can make a beam forming, like a beam antenna, and a really directed high gain antenna. And if you point these to each other, like in the same neighborhood, so comrade A points it to comrade B, and comrade B points it to comrade A, you can have a high speed tunnel, Wi-Fi tunnel, and it's almost not hijackable because you need to be in between the signals to actually hijack the signal. I think it's worthwhile. It is something to experiment with. I think it's nice. All right. So that's for the short range thing. Let's go next one. Okay. We have the consideration for the 5 kilometer, the village city district. Yeah, of course. Then you need to power up. That's what I use a lot. I have demonstrations, especially when I have marches. I use these Anytones, a little higher power, a little more use. still the 5 kilometers I'm not going to reach. Like more like 2-3 kilometers, and that's it. I'm really stretching it. So don't expect 5 kilometers from these things. But yeah, then you will need a repeater, and that's what I talked about. So it's nice. It's the best option actually. But if you have a repeater, if a comrade who has a repeater, we can run a node, put it on a building, in the center of the operations, and set it up properly. And these walkie-talkies also have TX on the different on the input of the repeater, and RX on the output of the repeater. Then you have wonderful comms, the whole action. Really, it costs a lot of money. It costs a little of putting it up, but it's nice. I still advise LoRa Meshtastic for this, but there need to be serious settings done in Meshtastic for using Meshtastic. By default, Meshtastic repeats, have nodes that also repeat. You need to turn it off. You need to make, I think, client mute or something. You need to make all of them that. And then have one repeater high on the rooftop, big, good beefy antenna on it, battery, and then put it up as a repeater. Then you can make the Meshtastic work wonderfully in like 5 kilometer range. Really nice. Meshcore, nice. The good thing about Meshcore is there's already infrastructure being around there, because a lot of these Dutch people are really invested in Meshcore, and they really want to so you can use them, you can lift them, but it's not super reliably. But at 5 kilometer range, you have like 1 or 2 hops, it will do fine. I tested it and it was really reliable in 5 kilometers, so no problems there. If you put up a repeater and you don't do it, set it up properly, then you also making infrastructure for the opposing party. So if you have activists that are not supporting your calls, so you have activists that are opposing your calls and are violent to your calls, and they are using LoRa, they are using Meshcore, and you put up a repeater, and you don't configure it to only be used by your private channels, then you also providing them with infrastructure. So you have to think about it if you're using Meshcore. You can also use Reticulum. Reticulum is really nice, but it's getting a little more geeky then. It's not that easy to put it up. If you have high gain antennas though, it works. I tested it with lower gain antennas. It's a little wonky. You need a lot of nodes in between and a beetje like that. But you will see, the further away we get, the more interesting this Reticulum gets. But for the 5 kilometers, yes, but I will not use Reticulum for 5 kilometers yet. Reticulum has a use way further down the line. And of course, at 5 kilometers, you can still use the Cantena principle and do some P2P stuff with your directed Yagi or Cantena thing. And Yagi is, they call it. Let me see, a Yagi. Let me look up what a Yagi is for you. A Yagi antenna, for who doesn't know. It looks like a fork, like a hark, I know you call it, and a rake. Because then we know I'm talking about. This is really a bad. I just want a proper image of that thing. Look at that. This is better. This is a Yagi antenna. Okay, where are we? Oh, where is that? There we go. There we go. This is Yagi antenna. It looks like a fork, but it is directional. So everything in the it is directional in front. So you have the smaller elements here. You have the driven element over here. And you have a reflector over here. And actually the driven element is in the back. So it means the direction is all the way to the front, pointing that way. So it's receiving better from that way and it's also transmitting better in that way. So you can make your transmissions more directional. There's a Yagi antenna with a Y, with a Y. Yagi. All right. Okay. So let's continue. Otherwise, I still clicking on the wrong buttons all the time. Okay, and now we're getting interesting about the 550 kilometer. This is really a difficult range to operate in, I find. It's all of the VHF UHF systems starting to break down really fast actually here. It's really difficult to have proper decent comms working reliably at 50 kilometers range cost effectively. Yes, you can put up a multi-thousands repeater high up in a tower with a big antenna on it, high power, and you can cover maybe 50, 60 70 kilometers, depending on the curvature, the height of the antenna or the earth. You can cover it reliably, but that costs a lot of money. It's starting to have diminished returns really fast. So it is a difficult range to work in, because these walkie-talkies are not going to cut it with a single repeater in our budget range, and so reliably. So it's difficult. With mesh core, it's starting to have these limitations I mentioned earlier, like with more hops and things getting missed in a line. So it's not really, for reliable comms, not really it. Now we're getting reticulum. Reticulum is getting interesting over here. It has the problems of LoRa. It is LoRa. It's just like mesh core is LoRa. But the good thing about reticulum, I find is you can connect different ways of propagation on there. So you can put a HF rig on there, and that doing packet radio. You have a NVIS antenna, and you also have these R nodes. And if the communication over the R nodes doesn't work, it switches over back to NVIS. It's really nice. You have to set it up. It's really not accessible for normal people, let's say that. But if you're geek and you want to help people out, and you want to help to set people up, and you want to have reliable comms, then I think reticulum is a valuable option for the 50 kilometer. But you need to invest in it. It is, and that's why the last point, the ease of use, is contradicting reticulum a lot. But I really like it. It has its place. So you see, the 50 kilometer range is a difficult range. Even the Wi-Fi is starting to ache a bit. It's a long range. The curvature of the Earth is going to play a part there. The I call it the I2 losses in the air, the open air losses going to account, because Wi-Fi have low power, and 50 kilometers is just a lot, you know. Even with a antenna or properly tuned Yagi and like a beam antenna, it's going to stretch its limit. That's why NVIS can be an option. If all these options here are exhausted, then switch to NVIS. NVIS will be there. But with NVIS, the time of the day, solar spots, the weather type, the proper, the conditions, they call it conditions in ham radio world, need to be right. And you need to know what you do. So your technical skill level is there. You need to roll out an antenna. If you don't have space for your own antenna, I don't have antenna. I live in an apartment. I don't have space for a big antenna. I need to go outside. I need to roll out an antenna and test it. It's more elaborative, but it works. If you put it up properly, the conditions are right, it will work, and it will working for at least a couple of hours. So NVIS is an option there. So examples. What I'm doing here? Didn't I do? Hey, I didn't. I've missed some sheets. I missed some. I think I missed it. I have a lot of these things. So really, no, I'm really sorry. For the 500 kilometers, I can be short. It needs to be NVIS. There's no option. There's no other option. There are some people who manage to with mesh core to have long range, like multiple hundreds of kilometers or something, but not reliable. It's like really like in the Guinness Book of Records type of achievements there. It's not for reliable comms. It's not for strategic comms. Now 500 kilometers, NVIS. I cannot think of anything else. And for the 5,000 kilometers of longer, you're going to use HF Skywave, the normal Skywave, like with the skip zone, like what I showed you on the image earlier with the blue and the red pills for the reception of my signal. There's not really a lot others you can do if you're not using like managed networking systems like internet and cell phone towers. All right. So what we going to what examples going to use then, right? Okay, with the 0.5 DPMR walkie-talkies, cheap as walkie-talkies. These, okay, 5 kilometers up to 5 kilometers. The more high-powered walkie-talkies with a good antenna on there. It can be UV5R, but you need a good antenna on there. With the 50 kilometers, it's always a compromise. It's really difficult range. And and for mobile phones. Oh yeah, I didn't talk about that one. The mobile phone is like a walkie-talkie, but has a bigger power. It's more. I don't have one. I really want one actually. It's just you cannot put it in your pocket. It's like it looks like a car radio actually, and it's being used in the car also a lot. And these have higher output power. It's actually the same as a walkie-talkie, but they just have higher output power and capabilities of connecting different types of antennas with different types of connectors. That's actually it. But if you use them with a repeater, a good repeater, it's going to be costly. If you have the money, if you really want to put it up, then it's the way to go. Otherwise, HF NVIS is there. 500 kilometers, NVIS or Satcom. Yeah, Satcom is there also, yeah. And Skywave for 5,000 kilometers, yes. All right. Okay. Now we come to the, how to achieve these ranges with the devices I just mentioned, because I just mentioned some devices or some techniques, and how did I come up with these ranges then, right? So because how do I know that? Yeah, I tested it, and that's the thing. You need to test it. Antennas have, and I come up with the top 3 of which is the most influential of achieving a certain range, and the most beneficial is your antenna. If your antenna is good, it's matched properly, and matched I mean the impedance is matching with what the transmitter expects. You have to Google it because otherwise it's going to take too long. It's called impedance matching, and it needs to be 50 ohms of impedance. If that's good, that means that your standing wave ratio, that's SWR over here, you have to Google that. Sorry about that. Is low. You want a low SWR. So if you have a radio somewhere, you have like a ham radio, or you're using someone's radio, or you're watching over someone's shoulder using a radio, and you see SWR, you want this as low as possible. And there's always like 1 over, like one double dot over something. And often you see like 1 over 1.5 or 1 over 1.4, something like that. Sometimes you see 1 over 1.3, or 1 over 3 maybe, and that's a little high. Rule of thumb, you want it under 1 over 2. So that is what I advise. The placement height is really important. The higher your antenna, the better it is. Except for NVIS. NVIS, you have specific heights to work properly. For NVIS, it doesn't really matter, but for the rest, all other antennas you're going to use, the height is might. The higher it is, the better it functions. Especially for VHF, UHF, the higher it is, because the curvature of the Earth is a limiting factor at range. And antenna gain. I worked my way up, I see. I didn't work, okay, doesn't really matter. Antenna gain. The higher the gain is in dBm, like dB milliwatts, or dBi, dB isotropic. And dB stands for decibel, and a bell is a relative metric. Going to be, you have to also look that up for yourself how that actually works. And that says that every 3 dB you add to a certain value. So if you add 3 dB, 3 decibel to a certain value, you double that value. Actually, that's it. So if I have an antenna with a gain of let's say 10 dB, 10 decibel, really high gain actually, and I add 10 and I add 3 decibels to that, then the effectiveness of this antenna is doubled. That's actually it. So the higher the gain, the better. But also the higher the gain, the more directional it will become. So that's also you have to look up for. So if you're selecting an antenna, you have to look for the radiation patterns for this antenna. The most high quality antennas have these from the factory. They supply them in like a data sheet. They have the radiation patterns. They tested it and have the radiation patterns fitting for these antennas. And sometimes they don't fit what you need, because for HF and UHF you want a flat radiation pattern, so you can go all the way around. But if you do HF, you want to have also a little slant, like between 5 and 10 degrees up, to have long skips on reach far. For NVIS, you want it straight up, so you need to your radiation pattern needs to fit what you want to use it for. And you can look them up for high quality antennas. Like the Amazon antennas, you don't always know what you get, so that's difficult. Okay, so your antenna is, I think, the most important part of your radio. Okay, then we have the feed line of your coax cable. So your what is connecting your antenna to your radio. Well, the easy part is with HTs or with walkie-talkies. They are connected to the radio, so you don't have to worry about coax cable. But if you don't have a HT, or you use an antenna of your HT externally somewhere, you need to have a cable connected to it. Now, we use coax cable for that. It needs to be 50 ohm cable. Impedance of 50 ohm. You need to look it up again. It needs to be of good quality. Now, short, low loss coax of decent quality is preferred, I say. For mobile use, if you on the go, you pack a backpack, you put your radio in there, you want lightweight, you don't want it too heavy, take the beefiest cable with the lowest loss you can comfortably use. And the shortest you can get away with. That's the rule of thumb. And now we're getting to transmit power. Transmit power only comes last. Most people, including me, was talking in the beginning, it's about transmit power. Let's put out, I want my F license and I want to push out like 400 watts. That transmit power is like last coming there. See, transmitting power only comes last because the antenna and feed line are selected and prepared for the area of operations. Like adjust your transmit power to cover the area of operations, like a fine tune, but no more than an area of operations because of security risk. If you overpenetrate your area of operations, you want the least people to listen to you. You only want the people to hear you who you intend to reach. And if you reach, if your area of operations is like 5 kilometers, but you're reaching like 100 kilometers, then you're overpenetrating your AO, and not necessary. So you can lower your power to tune for that. Make sure your equipment can comfortably drive the power. These HTs can do 5 watt. These PMR things can do 500 milliwatts, and the LoRa devices also can do up to 500 milliwatts. But a ham radio can do between 10 and 5, in the Netherlands allowable 400 watts, but some of them can do a kilowatt or something. We have big expensive rigs, and not worrying about that. If you're looking for a radio and think about power, if you want to do it locally, like 5 kilometers, 5 to 10 watts is max, and you don't need more. Don't overdo it. If you want to do reliably long distance stuff, then you're talking about 100 watts and more. Yeah. All right. There is a benefit in tuning and selecting your antennas and feed line to well-working ones, because it works for transmitting and receiving. So this one is transmitting and this one is receiving. But if the transmitting antenna is good, it also receives good. And if it's a double effect. So it also transmits better, but the other one receives also better. And if both of them are good, it actually is a squared function. So if both antennas are doubling, it's actually quadrupling in effectiveness. And that's really great. Whereas you're increasing the power, it only benefits the receiving station, the one that does the RX, because you don't get antenna gain if you increase your own transmit power. You don't receive better, you only transmit better for the other one to receive better. So by improving the coax line and the feed line, you will improve your system both ways. So it always has the benefit to focus more on your antenna and feed line than on your transmitting power. Yes. All right. So concluding considerations, because this was a long one. Concluding considerations are for range, test yourself and your action group what works. Test for yourself. Oh yeah, sorry. That's what I wrote down. There are a lot of variables that decide your effectiveness of range. There's the conductivity of the Earth's surface, the height of your antenna, solar winds, and there are a lot of variables. You just simply cannot, a human being cannot simply account for all of them at the same time. So there will be a lot of variability in your actual range. You can ballpark your range and you can test it, and testing is what we do. So there are a lot of variables that decide it. The 5,000 rule will only work approximative. Yeah, so it is just a rule, like a rule of thumb. It's not really a fixed thing. Yeah, only by testing your equipment for your setting and your AO will know what you will work, what you need, or what needs adjusting. So what I really do, I turn on my HF rig, I start recording my rig, I walk outside and I start walking around in the city with these handheld things. I just TXing all the time, and I listen back where it misses, where not. So I can map in my head, okay, about this. Okay, I just test it because there's too much variables to test to work around it. So that's how I know a bit about. And you need to do it too. It's elaborative, but it will give you an idea of what the range of your equipment will be. It's good to do. And walking is also good. So that's nice, right? All right. Now we got to utility. Casual, tactical, and strategic. Yeah, why I choose these three? Well, we get there. The nature of your comms are decided by three basic utilities. We have casual comms for low-risk radio communication that focus on ease of use. And yeah, that's actually it. That's just like I was saying there. Then we have tactical comms, higher-risk comms that focuses on speed. Well, tactical means there's a situation and you need to act now. There is something happening, you need to communicate it to your buddies right now, to your comrades right now. Your comms need to do it, they need to deliver the message. That's speed. And strategic comms. That's more like planning stuff. Longer range, higher risk comms that focus on security. You rather have, with strategic comms, you rather have your comms being dropped than being intercepted. That's the with speed you want it being delivered fast, no matter how, and with strategic you want it to be delivered safe, and if not safe, then rather not. Yeah, that's the difference between these two. Okay, most utility requirements are a mix of all three, and therefore always a compromise. There are no pure strategic comms, and no pure tactical comms, and no casual comms. There are types of comms that leaning more to one or another, and by selecting what you need, by asking yourself, okay, what do I need? What does my action group need? You can select a nice compromise that works for your action group. Example, I have a nice example. A smartphone is easy to use. It can be used in light tactics and be used by using the right apps, can be somewhat secure and being used for strategic communication. That's why mobile phones are being used in all three settings. They are easy to use to call your family. They are being able to call your comrades during an action. Where are you? Can you please share your location because the police is here, the agitators are here or something, you know? Can you share your location? I want to know where you can meet up. Phone can be used for light tactical communications. And also for planning, action planning. The phone is being used. Actions are being planned over apps. That's just how it goes. The phone fulfill all roles, but doesn't fulfill them all perfectly because it's a compromise between these three. So, and that's why I make this nice triangle. Yes, I like the triangles. I should have put an eye on top of here, right? Actually, okay. So we have the casual. We have the casual here in the left corner. We have strategic on top and then speed tactical there. And I put these on these ribs. I put reliability between strategic and tactical because I think that meets them both. And casual and tactical, I mean accessibility. I think that meets them both too. And between casual and strategic, the infrastructure need to be there. Because by tactical comms, it's more ad hoc. It doesn't need to be most times doesn't need to be there permanent infrastructure. Whereas by strategic and casual comms, we mostly speak of infrastructure being present. So what we put in there. So this is how I fill it in. I think if everyone fill it in, they fill it in on a different way. But this is how I think it looks actually. And in top here we have the Enigma machine. In 1939, before it was cracked, because after it was cracked, it was more like a really it's not even accessible. It was like, I don't know where it's supposed to be. It was a piece of shit then, because it was cracked. It was not strategic anymore. But look what I put down here. I put a reticulum here because it fits there really nice. It is not fast. It's not easy, but it is strategic and it is really working well. Really, it's really. And that's why I say reticulum earns its place when the distance is going up and the communication is shifting to strategic over a tactical. I won't use reticulum during a low-risk action where I need to steward a group. That will be total bonkers. It doesn't make sense. We use HTs, PMR, like these walkie-talkies. You go for accessibility. You go for ease of use. That's what you use there. So this is how I visualize which comms are on what place. And I think maybe if you planning to set up a comms reaction group, there's a way you can do too. You can make a graph like this and put the comms in there and think. Yeah, I think it makes you really think about what fits where, and I think it's really good to make this process, even though all of us will probably fill this in differently. This will be different. Maybe some people think internet's supposed to be more like here or there. I don't know. I just feel it was did like this, and I think maybe sometimes worth discussing about. So that's it. So we have these utilities. Utility casual comms consideration. Easy to use. It needs to be easy use. Otherwise, it's not casual, right? It needs to be ergonomic. It doesn't need to be a big rig you put on a shelf or something. No, it needs to be like this, like a device with a battery in there, and you just hold it and use it. Readily accessible equipment and parts. You don't need to be convoluted. If it needs to be repaired, it needs to be easy to repair or replace. It doesn't need to be like on some shady hacker website in the United States and a delivery time of 2000 years. No, it just needs to be readily available components, parts, usable, like this. Low learning curve. That's important. It needs to be easy. You need to be able to explain it to a kid of 5 years old, well, maybe 8. Let's say 8 years old, within a minute or 3. All right? Okay, this is easy. You turn it on with this knob. It goes on, and you press this button, and you can talk. And if you don't hear anything, you twist this button, and you try to talk again. So that's it. So it's easy to explain. It's nice to know almost no learning curve. And it just works. Casual comms just work. Who likes it to have WhatsApp communications with their family? And every time they open WhatsApp, they have to reinstall WhatsApp and re-enter the name, re-enter the phone number, and do some confirmation email, confirmation SMS text. Every time they open WhatsApp, they have to do that. Who's going to use WhatsApp after that? No one. It needs to be just working. It is right. You don't need to be setting up all the time stuff. And also important, it is a factor, not easy to break any laws. With this thing, it's not possible to break the law because this thing cannot transmit more than 500 milliwatts outside of the bands it's permitted to transmit on. So you cannot break the law with this thing. With these things, I can transmit on C2000. I don't like that, and I don't want to do that. But you can do that, and that makes this thing not casual, because you can casually, accidentally transmit on things where you don't want to transmit on. So you need to be more careful. So that's what I think is considered casual communication. And casual communications have its place, because every time when you talk about communications between comrades and things, we talk about tactical communications or strategic communication, but casual communications is what makes us humans and makes us connecting with each other and wants to share stories. And we still want to do that if the internet goes down, if the phones go down. We just like to talk to each other, and if it's not physical possible because of I don't know, if there's some army in the street or something, I don't know, if there is some fires again, something, you cannot talk, but the internet and the phones are also down. You can use radio to just talk, and you don't need high-spec radio for that. Yeah? So example is an FM radio receiver, just radio, just to listen music, just to listen broadcast. Radio is wordful. HF Envis, it's nice. It covers like about 500 kilometers. It's nice to have. It's not casually. I don't actually know why I put it there. Actually, it's not supposed to be there. I think the kids' walkie-talkie is there. These make sense. Envis not. I think I make a mistake. Envis is nice to use, but it has a high learning curve because you need to properly set up your antenna. I think I make a mistake there. That's really stupid. Envis is not supposed to be there. I think it was wishful thinking of me. I wish it was true. If Envis was so easy to use, then no, not Envis. But the kids' walkie-talkies, yes, for sure. These things, yes, you get them at the action, and they just pop them out. You just put batteries in there, and they work. Yes. Tactical communication. Fast to use. It needs to be fast. You need to be able to draw out your handset and talk. That's it. It needs to be, you press the button, you're able to talk, you communicate. Something happening there, you want to communicate it through, and you need to get through there. Okay? Encryption, nice to have. but getting really expensive because we're talking about military grade equipment over here. Because it need to be rugged, it need to be working in adverse situations, you need to be able to pick up the radio and it needs to transmit whatever you're going to have to transmit, and you need to do it fast. So it's really focused tactical information. Tactical communication is really focused on get the message from A to B, but not least on security. Yeah. Learning curve is allowable because you need to. Sometimes these military grade equipment have some knobs, some bells and whistles. You need to know which one to turn and which mode you need to use and which frequency you need to use. You need to learn about that, but it doesn't need to be that convoluted, that difficult that you forget it. The point of tactical communication is that you remember, or you can easily look up what you need to set, and you can directly do whatever you need to do to make the comms established. That's the thing. Latency, of course not. So email, no way. No, email is not for tactical communication. Mail, like letters or postal pigeons, no, there's not. There are examples of postal pigeons being used, like in the trenches, like in World War I or World War II or something, delivering messages. Even though there were tactical communication, was it? I think it's more strategic. It deferred to strategic communication because the tactical purpose was gone because the pigeon took a lot of time. So yes, if there's no other means, you use you use higher latency communication methods. But the point of tactical communication is next to real-time communication. You want to put A to B, you want it fast. So example, durable rugged walkie-talkies and repeaters. You have this military big-ass walkie-talkies, look like the early 80s mobile phone things, you know, and the dark green with a big beefy antenna on there, weighing 2 kilos. These are those, and you can hold them. You can put them in a backpack or something, and have an antenna on there. Or the manpack I showed earlier. That is military field radio. That's tactical shit. And these also can do encryption, but then again, you're breaking some laws, and it costs a lot of money. So yeah, if you want to communicate with the whole team, 10 people of it, then there's not a practical solution there. And also HF radio is usable for tactical, but yeah, you need to set up an antenna, so that takes the speed out. But yeah, if your area operations is further away from your command center, then HF sometimes is needed. Mesh-tastic is, I think, from all mesh style things, I think mesh-tastic. There's not mesh core, not Retilicum R-nodes or other mesh things or these bare-toothed expensive things. I think mesh-tastic is the best. It's beating everything if it's about pure tactical communications. But you need to have only private channels, no public channels, no repeating of public stuff. Strip anything public off, and then it will work only on it only repeats your messages. Everything is encrypted. Your telemetry is over encrypted channels, not over the public channels. If you set it up properly, then mesh-tastic is for pure tactical comms, I think, the best. The only thing is you need a phone, or you need these TDEC devices, and the TDEC devices are not waterproof. So see, there's a compromise there. See, there's always there is no pure tactical but I think mesh-tastic from all mesh things comes the closest. Over mesh core. Yeah. Now we get to strategic comms. Strategic comms considerations. Security is important. It's all about the security. Often requires long-range capabilities because strategic comms is more between tactical units, between center of commands, and I'm talking military nonsense over here, and but it's also usable in action groups, like for example XR or something, and they want to communicate from point Groningen to point Zeeland, for example, you know, and there's no internet, no phone. I was talking about this earlier. How are you going to do that? And if it needs to be hidden from the government because the government is a little bit flaky because there's no internet, because they are the ones shutting down, so they are already on a knife's edge. How are you going to do this? Yeah, you need security, and being hidden is important there. It's going to be strategic. This is no tactical operation anymore. This is how you build strategic infrastructure to deliver a message from A to B, and not being confiscated and not being arrested. in a situation where government is not so friendly anymore. All right. So that's where strategic comms comes in. Security is the most important. You have also privacy. Privacy is not being. What was it? How would I call this thing again? You have security is about it's secure. Comms are secure and not being found. And you have private. I don't know. I mix them. I always mix these things up, and Dutch is easier. But you have. What I want to say is, you can encrypt your comms. They're encrypted, but it doesn't mean you cannot be found because your signal is out there. So if you don't want to be a signal out there, you have to also think about the amount of power you put out, the antenna you use, the shape of the antenna propagation, in which way the antenna is propagating, then the directionality. So if you use a Yagi antenna for your strategic comms, the people in the back of your antenna cannot find you so easily. So there's considerations to conceal yourself also a little bit, and that's also part in strategic communications. That's also all of it is going to play a role in it. You don't want to be found out, and you don't want your message to be read. That's the thing with strategic communications. Often requires long-range capabilities. Rather sees comms not being established over comms being compromised. So with strategic comms is it you rather have message being dropped than message being compromised, being read or being intercepted, and you being found out. Yeah, that's the thing that makes it different than tactical. Learning curve is often steep. Cryptography is a pain in the ass. I'm not going to. I don't know shit about cryptography. I know a basic bit, but I'm not thinking I'm even there yet with the basic guys about this thing. Often there is a lot of false feeling of safety. People think things are safe, but they are not. Even these walkie-talkies, these had a prior, like 2 years ago, they had a firmware update, and this firmware update prevented from the how do you call this thing, the IV, some kind of rolling code. It's like it changes all the time, and using cryptography to make sure every key that's generated is different. It's like some kind of salt, but it's regenerated all the time. They call it IV, but I don't remember what the I stands for. But it was fixed. So that means if two packets were the same, it had a fixed encrypted hash. Yeah, that's a security issue, because then they can map different types of packets to each other, and they can make after a while they can map out what the message was. So, but people didn't know. No one knew. It was I saw it on a Reddit post, and I thought, I have this firmware version. This is really crazy. And I checked it. Yes, indeed, it had the same IV. It's really weird. And I updated it, and it fixed. So you can get a sense of safety, because it's advertised as being encrypted, but you don't know. I didn't know. I didn't even know what IV was back then. And you're out in the open. And that's why the learning curve to have proper encrypted communication is steep, extremely steep. It takes years, I think. Latency is second to security. Doesn't really matter. Encrypted email, PGP mail, doesn't really matter if it comes 10 minutes or 50 minutes later. Because the mail was encrypted for a reason, you know. Often used in tandem with tactical comms. So most times you have tactical teams, and they're communicating with each other. And then have central command, and then do the HF communications with strategic comms, if there are no other means of communication there. So often in tandem with tactical comms. And examples? Encrypted radio stations with HF NVIS capabilities. Yes, they're used in the military, they're used everywhere over the world. This is the way to go if there's no other means possible. Satellites are being used by the military, but we don't have them. We don't have satellites. Yeah, we can use like the Satcom satellites and pay €60 a month for a sat phone that works really crappy, not everywhere over the world, and can still be really tapped. We don't have military satellites. So the only thing we have is NVIS or HF. That's it. We don't have anything else over these long ranges. Military field radio, if you have one. But yeah, then still the frequencies, you're not allowed to transmit on them. And if you walk around with a field radio, just make sure they don't find you if you have one, and use one. Let's say that. Or use it on frequencies you're allowed to use. And especially not the encryption, because if they find out you use field radio for nefarious goals, then I don't know. Meshcore. I think that's a good one. This I think for strategic comms, Meshcore is better than Meshtastic, and that's because Meshtastic has these nodes. The default are auto routing everything. So for longer ranges, and this is really a problem for Meshtastic. The further away, the more messy it gets. The propagation of Meshtastic is really shit. Meshcore is way better, but still not perfectly. That's why I put up to 50 kilometers, because after that, at 50 kilometers already getting a little spotty. After like 2-3 hops or something, it gets spotty already. Or reticulum propagation network. Yes, I opt for that. Reticulum. I will really, with the NVIS and a LoRa connection, like a gateway between the both, and maybe some propagation. Not propagation, because propagation is delayed. With the gateway, just a normal gateway setting in Reticulum, you can also try to reach other countries who still have internet, and then you can have a tunnel over to their internet and reach them. So that's a possibility. Yeah, the baud rates are slow. It's really slow. It's not meant for streaming video, but it is to send an email. It is to reach someone you love abroad. It is for international communications. Reticulum does the job there. Yes, I really like it. For strategic communication, Reticulum is going to be it, for sure. So, utility. Again, takeaways and considerations. Ask yourself the question: what I am wanting to achieve. What you want to do with your comms. You want to have some demonstrations, and you want to have your stewards having walkie-talkies so they can communicate each other. If something happens in the front, or if something happens in the back of the march, then they can communicate with the front easily. That the front stops, so there are no gaps in the march. That's valid. You know what you want to achieve. That's nice. Just casual comm. You want comrade chatting. You want to just have nice communications with your comrades alone. Private Meshtastic channel. No problem. You can do that. Consider it. Consider what you need. You know, if speed is important, use walkie-talkies or use something that can deliver that speed for you. You need to figure that out. It doesn't make sense to use Reticulum and set up all different nodes and train people for a couple of days or weeks to use it and setting it up. If it's really slow and it can't do voice over at low data rates, so you have to think about that. No, there is no single use piece of equipment that can do all. The thing that comes the closest is actually the mobile phone. But yeah, in these cases, the mobile phone is not there. Once again, most utility requirements are a mix of the three, and therefore always a compromise. And that's really important. You're always making compromises in the radio. And it's up to you to decide which compromises you're willing to make. All right. Okay, now we're getting to the stuff. We're almost to the end, because I'm talking almost 2 hours, and we're going to get to the Q&A for the people who's there. So group size. There's 3 flavors here. There's a group of 2, there's a group of 3 or more, or central command. With 2 operators, you can think about P2P and direct link connections are parts you want to consider. Especially these antennae, like the Pringle can antennas, and these direct link or even laser links you can use, and you can share Wi-Fi connection. Yeah, you can achieve crazy ass data rates to actually stream a movie, to actually download something from the net with this. Well, if you live close to the border, this is something. This happens in the close to the border. If you live close to Belgium or Germany, and for example the Netherlands, the internet goes down, and in Germany not. You can make, and your friends in the other countries, close to the border, you can actually set up a nice P2P link and start up a network here, and you just have normal internet. Think about this. This is really worth it. If you have 2 people or something, and then of course you can scale it up to more people, but then you need some networking. But that's out of the scope of what my capabilities are. I'm not really a networking guy, so that's why with 2 operators, just 2 people, 2 directional antennas pointing to each other and sharing on a high data rate link. That's really nice. With 3 operators, that's not what you want, because there's 2 people talking to each other. Yeah, you can have one talking to 2 sides and bridging between, but then you just have a repeater. But it's just two and two. With 3 plus operators, you're more talking about broadcast, like walkie-talkies. If I press push to talk on these things, it sends out the radio waves, and everyone in the vicinity who can receive it receives it. It's broadcasting, and that's where most of the communications I use as ACAS is in the realm. 3 or more operators, we're using walkie-talkies to steward the group, and that's it, and that works. That's just fine. But cryptographically, or the security is harder to maintain because you're broadcasting. Yeah, if you're broadcasting, there are different eggs to fry. And it's harder to maintain. Also, the more operators you have, the more points of failure. There are more points of failure, but not in the way how I meant it. Normally, if you have more points of failure, that means more points need to fail before the system fails. But in this case, I mean it like links. You have more links in the chain, and if one of the links is compromised, the whole chain is compromised. So, the more operators you have, the cryptography is more under pressure. So you have to account for that. If you have 20 operators in a net and one of them loses a radio, it's a crypted channel, and you cannot account for the radio, the comms is compromised. All right. Central command. Sometimes you want to use central command. That is a person or sometimes a machine. They're brokers between 2 same level or different levels of communications groups. As ACAS, I do sometimes. If there's some different types of stewarding going on, or then I talk with one group, another group, because if they're all together in the group, it's too busy. So then I broker between. But you are a single point of failure. If I fall back, then there's no link anymore between the groups. So it can be dangerous. And you need to have skill between the strategic and the tactic comms if you do both, and it can be really exhausting. But it can be really efficient. So think about if you're using your comms, if you want, especially, and this is more especially with tactical and tactical to strategic comms, if you want to do like mesh-based, broadcast-based, or like brokered, and that's a consideration you have to make for yourself. All right, and then we have the environment. The environment is kind of important, especially at VHF and UHF. When your area of operations has a range less of 50 kilometers, so you're probably going to use UHF or VHF. Then in your rural areas, like on a field, if you can see far away, or at open sea in a boat, like the flotilla, the Gaza flotillas, you use VHF. No questions asked. You're not going to use anything else. VHF is going from 30 to 300 megahertz, and most times it's about 250 or something. They're about. You're going to use in these ranges, open spaces, VHF. No questions. In cities, cluttered areas, builded areas where a lot of things going on. Maybe in woods, but woods lean more to VHF because water in the tree trunks are more absorbent at higher frequencies than the lower. But just take a rule of thumb: if it's cluttered in the area, where there's buildings, people, whatever, now use UHF. That's why these, not these. These I use these PMR things for like small demonstrations. These are UHF because small demonstrations are almost exclusively in city areas, city centers, and these work just better in city centers than VHF. Okay, if your AO is about 50 kilometers, then we get a difficult range again. Then think about the crosslink repeaters. Crossband repeaters are like they're taking in UHF and they spit out VHF. And the way how it does is that for transmitting UHF, you need a smaller antenna. So you can have your HT, who's doing the transmitting. So the higher frequency, normally the smaller your antenna is, because the smaller the wavelength, the shorter the wavelength. And that means if you have a shorter antenna, you're more mobile, it is less to worry about, because this antenna, who's more optimized for VHF, which also can do UHF, is a long thing. It's going to stick out short tummy. If you walk this on my shoulder here, it looks like tactical communications, and sometimes you don't want to look at like tactical communications, you want to look like casual communications. It's a consideration you want to have. And that's why crossband repeaters are nice to have in there. Because you can uplink with UHF and downlink with VHF, because the reception of VHF you don't need a big antenna for that. It's better to do it this way. So this is a consideration you can have. Crossband repeaters are nice to have in cities. And yeah, if no repeats available or meshing is shit, NVIS. On 50 kilometers you can use NVIS, but it's convoluted to set up. It's not really tactical. It is who's going to walk around with a with 40 meter of wire for 80 meter NVIS in the night? You need it need to be more purposeful than to use NVIS, but it's nice. You can do it. When the range is more than 50 kilometers or less, consider NVIS in rural areas. And if you're in cities, I was thinking about this. It was really nice actually. If you're like in the Netherlands or something, the Netherlands is kind of dense, and you can actually make a LoRa setup, but you need to be really thoughtful of it. So you actually make it like mesh core, but you really be mindful about where you put the repeaters. You make sure you hide these networks from unwanted people. Only encrypt only people who have the IFAC keys, these IFAC keys. These are parameters you can put up in a reticulum config file. Who have the right ones can use it, so you can make a transport network between cities that work properly. Yeah, and between cities, you can expand it between 50 and 500 kilometers. I don't expect these LoRa things go to 500 kilometers, but I mean 100 kilometers will be possible if you set it up right. I think it's nice. It's an option, Anything about 500 kilometers, it doesn't really matter where you are, if it's rural or residential. Age of radio. You can use your HCall packet that can use reticulum, of course, or voice, phone. And I call it in radio world, it's called phone. And that's why I put it in these things. Because it's not the phone as we all know it. It's phone like voice, like we're talking in the radio with, like with this, with the PTT. All right. Okay. Simplicity, easy to use or skills. This is the last one. We're almost done. And I think this is the most important one of all. We're getting there to the conclusion of this. Easy to use or skills required. What is going to be this? Okay, and I think this is one of the most overlooked steps by people who are really interested in radio electronics or geeking out over stuff. We are enthusiasts trying to make stuff happen, but this enthusiasm can also conflate. Can be misread as we need it. So, an example here. Often, just use X. I use it all the time, And then they point to some bare PCB with an ESP32 and a LoRa chip in there. And okay, no, you can use it. Okay, yes, of course. But X requires a multi-day course on programming, electronics and testing, and not rugged, not weatherproof. So you still need to 3D print a case. You need to put rubber seals on it. If you want to use it out, or you need to be mindful way to put it. It's elaborative. In the end, the only goal was to have tactical A to B comms in the city center, low risk action. That was actually what was needed. So just cheap PMR 446 walkie-talkies from the action were the right tool in this case. It takes a minute to learn and they're easy to use. So. I think for the geeky types of us, it's important to sometimes make this confrontation, and that includes to me also. Sometimes the stuff we like and like to hack with is not the right stuff to use in an action. So in this case, the cheap PMI walkie-talkies were the right tool. Some considerations for my own experience. Does the tool I want to propose actually help us? Or does it only help my feelings? Is the time spent on learning to use a tool worth it? Because tools need to be learning. If it's easy to use, it's easy to learn. Almost automatically, I think. Sometimes it's worth to learn something and take a little time in that, but it's really important. That is worthwhile. That is worth investing the time in there. You have to ask the questions. Try to objectify the utility of the tool you propose. That's important. Do I prefer the tool, me, because I only like it myself because I'm invested in it, and this nice technology, yes, it works, and I can do this, hopping over this and that, and I can tunnel it over there, and I reach 200 kilometers over there. Yes, we're going to use it. No, it's hacky, it is spotty, it costs a lot of time, it's elaborative, and no one wants actually to use it. Do I prefer the tool? Because this is what the AG needs. That's the two questions. Do I prefer the tool because I only like it myself? Or do I like the tool because this is what the AG needs, the action group needs? That's a tough question to ask sometimes. So my own experience here, I like the tool for others. That I think, I like it. Yes, you are going to like it too. You're going to like it too. This is good. This is going to work. Yes. And then because I like them myself. And this can be risky because the tool I like are not always the tools we need. So that's something you need to be honest about yourself, what you're going to use. Okay. So if there are comms, radios, or equipment you are considering for your action group, always ask yourself the question, how long is it going to take for other comrades to get on board with the proposed comms tools? What I see often is that even with these simple, easy to use walkie-talkies, sometimes comrades don't know or are fearful of using them, even after explanation. And if that's the case already with this, how the hell we can expect comrades to use and set up something like this? That you have to be really honest about that if you want to set up a comms. And there are cases where that infrastructure is wanted or required, but then you have designated people between action groups that actually coordinate with each other and to set it up. So you have to be really honest to yourself, be honest, and do honest research. What's going to fit the bill? No, that's it. And that was it. We're done. This thing was 124 fucking slides. I'm really sorry for the people who are still here. I don't know if there's any here. Oh, there's still 6 people here, including me. So you are really putting it through. Thanks for surviving and watching. Let's do some Q&A. And let's see if I have some questions in the chat. How long is a skip zone for NVIS? Oh yeah, I think I answered that already. Depends, depends on how your antenna setup is. But normally it's 0. You have no skip zone. Can you use encryption for the voice comms too? Yes, you can. With the Baofeng, it's not really encryption. The Baofeng is the same thing as with these thing, and they call it privacy tone, or they call it I forgot the name of this thing. What it actually it does some modulation on the voice, on the audio frequency spectrum. It does some modulation with some different filters or something. I don't know how I do it. And then the other device of the same type reverses that if the setting is on. So it's not really encryption, because encryption requires a secret key. And if you can buy these things in the shop just freely and can just use it to decrypt these audio frequency encryptions, it's not encryption. It's how you call it? Making it a little bit harder. That's it. So yes, for common folk to keep out people who just listening in with the Baofeng or something, it works, but it's not cryptographically safe. And just with the same tools, it can be hacked. I can't even call it hacking. It's just using the tool it's intended. You're just listening in on these obfuscated voices. With the Anytone, just a step up from a Baofeng with this one. Let me go to the normal thing because my sound. Yes, with this one, with the Anytone, you can use encrypted data like a DMR, digital mobile radio. There are different variants of that. With digital mobile radio, you can encrypt it with AES-256, and that's actually encryption. But that one had a firmware failure where I was talking about that, and I call it that IV, the internet. I don't know what IV is. IV vector international in IV vector encryption. Let me look at them, and I want to know it. Initialization vector. Now I know it. Okay, all right. That was the same, and it's supposed to be rolling. It's supposed to be a different type. So encryption is important, can be important at some point, but you need to know what you do. That's the thing. If you trust on third parties, you might as well just use the internet because it's also third party, So it's difficult. I went down a rabbit hole and I came back not crying, but enlightened about encryption can be difficult. So yes, on voice it's possible, but you need a digital mode, and the normal Bauvings cannot do it. So that's the answer to your question. Where did you get the box for LoRa device? The box itself. This electrical box. I have no clue. I have this thing. I had a company in building equipment for escape rooms. I made bomb games for escape rooms and props, and I have no idea. I think I ordered this from. It's a Schneider box actually. So yeah, I can see if I can read it. Schneider Electric is a common name brand for these boxes. They're kind of expensive. I think it costs 20 euros these or something. But you can look on Amazon. Just look on Amazon for electrical box waterproof, like IP67 or something need to be, and then you can find different versions. This is good. It's just polycarbonate and ABS. This is polycarbonate and this ABS plastic. That's it. All right. The box. Can you recommend antennas for LoRa mesh core repeater devices? Yeah. Can I recommend? Yeah. Yeah. There are these things. Let me look them up. These are outdoor antennas. They look like a gray PVC pipe. They're sturdy. They go on an end connector. They fit well. Outdoor. Let me antenna. And I ordered a few, but they didn't arrive yet, so I cannot show them. LoRa 868. Let's see, because I don't want to show you the Amazon stuff because it's sketchy. Sometimes sketchy, not always. The fiberglass stuff, yeah. Something like this. I put something for Kiwi. Put it in the link there. This is the wrong link. That's crappy. Let me close this one and try to log in here and chat here. Enter there, and I think it's there. I think something like that. Something like that will get you there. Where is the thing? So something like this fiberglass antenna will do it. It has only 3 dB gain because it's mostly just a dipole in there, but it will be fine. This one has an end connector. You have to look very carefully about it. Oh, I'm not. Let me. It's to my face there. Yeah. There we are. Okay, again. So this is it. It looks like a PVC pipe with a knob on there, like a leg from these. I don't know, from like some cheap chair or something. But it's actually antenna. It has an N-type connector on there, so you make sure that you also have the N-type connector on the other side. They look like this. This is N-type connector, and I prefer this connector. This connector is able to do the higher frequencies, and it's sturdy. You can put the antenna on there, and it stays. Especially if you use it outside for the wind, it stays. These small SMA ones, I don't prefer them for outside. So make sure you have a fitting connector for that. But these you can just get on Amazon, these connectors. Okay, question. LoRa devices, can you recommend antennas? Out of the criticisms when the Dutch government tried to ban internet encryption in the 1990s. Oh, okay, such a ban isn't feasible because you can't distinguish encrypted data from nonsense. That's interesting. Is the government now banning sending nonsense? Do you think a certain amount will not encrypted audio? However, I've checked whether something. How if it all is checked whether someone is sending encrypted message? Well, encrypted messages can be detected using AI. An LLM can detect the patterns of of encrypted stuff indeed. So you need to obfuscate your message for some reason, but then AI can still penetrate through it because key lengths are a factor, because these messages are sent in different have different key lengths. So that's already a parameter they can use for it. I think they can distinguish rather quick. I have no proof for that. I didn't read articles on that or something, but I think it's kind of easy nowadays with AI to distinguish nonsense from AI. Yeah. Such a band not feasible. You can data. Do you think similar argument holds for encrypted radio? Encrypted radio, as a hammer, I'm a hammer operator, and encrypted radio is in the realm of forbidden. I think it's, people are already getting scared if you talk about it, some ham radio operators. I don't mind it. I don't mind encrypted radio. But I try to abide to what the rules are, because I don't want to lose my license, of course. And but there it's already forbidden. It's allowed on the ISM bands. It's allowed on the 868. I think on 433 is allowed at low powers. I think it's not explicitly stated, but on PMR 446 it doesn't say it's not allowed. And actually DPMR, so it's digital mode of PMR, is allowed. So you can actually encrypt DPMR. So I think you can just encrypt also 446, but you need to use DPMR, which is no problem. So yes, there are possibilities to still have communications, but in the legal sense, it will be low power. The highest power I think that's allowed to do encryption is 500 milliwatts, because even on Citizens band, where you're allowed to send up, I think 4 watts or something in FM, you're only allowed to do FM voice, you know, and FM voice doesn't allow for encryption. So technically, the options are limited legally for encrypted comms. Yeah. Thanks. Another question: what happens if you accidentally send something to P1000 or T1000? Aware of any prosecutors? No, I think if you accidentally do it, it's no problem. But I don't think what I don't want to do. And that's the thing. That's why I warn from it. Some people don't warn from it because think people I can live my own life. You know? So some anarchists, especially FWA, no, the government cannot hold me back. But I warn for it because what I want to prevent is a lot of people trying communications are not aware of where they're spitting out their data, and then suddenly enforcement is going to be there, and then we have a different problem. And then that's something I wouldn't like. So hey. What you're going to do if this stream closes, I don't care. I don't mind. Just do it. But I just give advice to be mindful. Don't steer the pot where it doesn't need steering. You know. Let's don't do that. Another question. What happens? That's so. I'm not aware of any prosecutions, but legally so. By punishable law, if your action, if your transmission on C2000 on encryption radio leads to information not reaching some kind of police officer or EMT, like fire department, and they cannot do the job, then you're on the hook for impeding. Yeah, yes, and that can be jail time. I never heard of a story about that, but I don't want to be the first one, you know. So let's don't do it. It's a general advice to don't do it. And also, it can be anyone who needing EMT services. It can be also, it can also be my house next. There's a fire, and then someone else is spitting out a lot of power to the frequency, and then the fire never gets reported. So, no, let's do that. And I had a question on the other channel. I want to answer still. There we are. Where was it? There we are. Okay. Question answer. Best bang for buck hardware, preferably with good throughput. Too much latency and too little bandwidth mates often you start to dislike. Okay, in this case, if you want good throughput and low latency, and you want higher bandwidth, and then I have a condition. They need to be less than 50 kilometers, preferably 25 or less. The Catena Wi-Fi bridge, the direct peer-to-peer communication thing. Then you can stream it even. Just experiment with these Catena things or Yagis for 2.4 gigahertz, and try to with some comrades in a neighborhood, try to make a link and bridge it over the network, and just try it. And I think that's the best thing. So if you're listening, try that. Try to make a Catena and use it on 2.4 gigahertz. Yes. So that concludes this demonstration. This presentation. See, I'm an activist in my demonstration. If there are no any questions, I'm going to end the stream, and I wish you a lovely night. And I'm going to have a sleep because I'm now really tired. Yes.